All right, so let's use trig to find some missing pieces of a right triangle. All right, so the next problem here. Okay, it says a plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of descent? Okay. Excuse me. Okay. So obviously in this picture, right, we need to ask yourself the question, is x greater than or equal to, maybe even greater than, but whatever. I'll say just greater than, right, because let's go over it. So is our x greater than 11,088 feet? That's the question, right? So we got to find x, okay? So we have an angle, we have a side length, and we want to find a side length. This is a perfect situation for trig. So, ka, toa. When you have a right triangle and you have, one angle and a side, or you have two sides, you can find the missing side or the missing angle. So first off, 12 is my angle I'm given, so I'm going to use 12, right? So what two sides from 12 do I need to find? Well, I need to find x. X is across from 12. That means that x is the opposite side. And then this 12.5 helps make the 12. That is the adjacent side. So the hypotenuse, which is the flight of the airplane, we're not going to use. So if we're not going to use hypotenuse, watch what I do here. We're not using hypotenuse. We're not using hypotenuse. It has to be tangent. So that's how you eliminate, right? And when it's not a question saying what is the sine, cosine, and tangent, when you have one problem to do to identify the trig ratio you have to use, you have to say what sides do I have or need, and just use that trig ratio. So we're going to use tangent, okay? So here's our trig equation. So tangent of the angle, tangent of 12 degrees, equals the opposite x over the hypotenuse, 12.5. We need to get x by itself. X is being divided by 12.5, so we simply multiply both sides by 12.5. And this is what we're going to type in our calculator to get what x is. Okay? All right. So I'm going to lose this real fast. I think I'm going to clear it away. So 12.5 times tangent of 12. So I'm going to go there now. I'm going to reopen. I'm going to reopen Desmos for a reason, right? Every time you use Desmos, wrench, degrees. There we go. 12.5. You don't have to put times. You can put times. Tangent, tan of 12. And this is our answer. We're going to round that to 2 decimals. Okay? I'm going to finish the question right here. So if I round that to 2 decimals, there's the 5. The 6 rounds the 5 up to a 6. So our value of x is 2.66, and that's going to be in miles. Okay? Now, as a sidebar, say that your equation was this. Tangent of 12 equals 12.5 over x. Say that the x was in the denominator. You're going to use this. It's a very sophisticated method. It's called the switcheroo. Now, I could show you, right? I could do this. I could set up a proportion and show you that, just like we did before, you can switch those two things because they're going to be cross-multiplied together, right? But in the end, all I want you to know is that the x comes out and the tangent of 12.5 goes in the bottom. Or the tangent of 12 goes in the bottom. So instead of taking 12.5 and multiplying it by the tangent of 12, you're going to take 12.5 and divide it by the tangent of 12. Okay, so let me show you what you would type in. So over here, you would just type in 12.5 divided by tangent of 12. And again, hopefully you can see through that, and that will give you a way different answer. Okay? But sometimes you have to divide. So be aware of that. Hopefully that makes sense. It doesn't confuse you. Okay, I'm going to get rid of that. Okay, so now, what do we do here? Well, this is in miles. We need to convert that to, oh, and again, somewhere right there, degrees, right? Write down degrees, right? The wrench makes you change your calculator to degrees. If you're using a handheld calculator, it should probably say DEG. If you have a graphing calculator, there's a mode button to change to degrees. Okay, so now let's convert this to feet to see how we're doing. So 1 mile is 5,280 feet. So we need to take this 2.66 and multiply it by 5,280. 5,280 feet. When you do that, you get roughly 14,044.8 feet. And of course, that is greater than our, what was it, 11,088? Jeez, oh Pete. I tried to make the shortcut, but I put the comma in the wrong spot. 11,088. So because that is greater, we are good to go. Yes, the plane is going to clear the mountain. Yes. The plane will clear the mountain. Cool. So that's using trig to find a missing side length. Okay. All right, now let's take a look at using trig to find angle measures. Okay, so for this triangle, we're being asked, what are the measures of angle A and angle B? So notice up in the direction it says use trigonometric inverses. So when you use trig, you're finding side lengths. But when you use an inverse, you're finding an angle measure. Very, very, very important. Inverses help you find angle measures. So notice in this picture, we are given two sides of our right triangle. We need to find the measure of angle A and the measure of angle B. So really all you have to do is you have to find one of them, right? Because you know that they're complementary, so if you find one, you got the other. So let's focus on angle A, right? Angle A is my angle, all right? So we do the problem very similar. We set up SOHCAHTOA. Now, what sides do we know? Well, we don't know the opposite, but we do know the hypotenuse is 4, and we know the adjacent is 1, right? So we're going to use the adjacent and the hypotenuse, right? Adjacent and hypotenuse would have to be cosine. So I'm going to set up my equation. So cosine of angle A equals adjacent 1 over hypotenuse 4. But now to find the measure of angle A, I'm going to use what's called the inverse. The measure of angle A is going to equal the inverse cosine. So it's a cosine with a -1 exponent. Inverse cosine of 1/4. Now, some people also might call this the arc sine. So you might see this as well, equals the arc cosine. Sorry, arc cosine. Again, I'll try to write clear. Arc cosine. Both are the same, right? Both are the same. But this will allow us to find our angle measure. And what we'll do is we'll go into Desmos. Again, we'll make sure we're in degrees, and we'll type this in together. Again, this is like an exponent. It's just notation, okay? All right, so it's going to go away. All right, so going back to Desmos. So again, make sure you're in degree mode. We are. Okay, so I'm going to type in cosine. I'm going to raise it to the -1st power. Again, that's just notation. And in parentheses, I'm going to do 1 divided by 4. And this is an angle measure. This is what angle A is. We'll round to 1 decimal. So the measure of angle A equals 75 point. The 2 does not change the 5. 75.5 degrees. And there we go. Again, you could also use this arc sine if you wanted to, or arc cosine, ARC cos, if you don't want to do the -1, and you get the same thing. Okay, so same idea. All right, so now, if we take a look at this, and again, I'm just going to write the answer down. So we now know that the measure of angle A is 75.5 degrees. Now, we could easily find the measure of angle B by just taking 90 minus that. So the measure of angle B equals 90 minus 75.5. That's going to be 14.5 degrees, right? So believe that, right? But let's use trig, right? I'll draw the triangle again with you. Here's 1, here's 4, here's B, here's A, here's C. So from B, we know the opposite is 1. We know the hypotenuse is 4. So SOHCAHTOA, opposite hypotenuse is sine. So to find angle B, we're going to use the sine of B equals the opposite over the hypotenuse. So now we need to use the inverse sine. So to find the measure of angle B, I'm going to take the inverse sine of 1/4. Again, you could also use the arc sine. The arc sine of 1/4. And I'm hoping that this gives me an answer of 14.5. All right, so let's see. So again, if you come here, I'll do inverse sine. Oh, let me get off this. Got my, that's why. Sine raised to the negative first of 1/4. And there you go, 14.47 is 14.5. And that would be the measure of angle B. Okay, now the last thing I want to show you. So we know the measure of angle A is 75.5 degrees. We just found the measure of angle B is 14.5 degrees. And again, I would not use inverse twice, but just to show you why. So now, what if I wanted to find this missing side? What if I wanted to find what BC was? This would be called solving the triangle. Solve the triangle. If you hear the expression solve the triangle, that means they want to know all three angle measures, all three side lengths. So obviously, we could use Pythagorean theorem. So I'll do it real fast, right? A squared plus B squared equals C squared. So let's say this is A, 1 is B, of course 4 is the hypotenuse C. So we would do A squared plus 1 squared equals 4 squared. A squared plus 1 equals 16, subtract 1, A squared equals 15. Take the square root. I would not round this nicely, I would just take the square root of 15. And the square root of 15 is going to be something like 3 point something. 3.87, sure. So there's A. Right, that's the missing side, 3.87. Okay. Now, what if I want to use trig to do that? Let's do that. Let's use trig. Now, you found angle A first, so let's use angle A. So angle A was 75.5 degrees, right? So let's use 1 and 4. So from angle A, 4 is the hypotenuse, 1 would be the adjacent. So SOHCAHTOA, adjacent hypotenuse is cosine. Oh no, I'm sorry. I'm getting ahead of myself. What am I doing? I know those two sides. Excuse my haste. So from 75, right? I want to find the opposite side. So again, let me start over again using trig. Sorry about that. This is 75.5 degrees. I want to find the opposite, so then I just pick one of the other two sides. Well, I used tangent in the last problem, so let me use the hypotenuse, the 4. So let's ignore this one. So let's use opposite and hypotenuse. So SOHCAHTOA, opposite hypotenuse, that would be sine. So to find this side A again, I could use the opposite over the hypotenuse. So sine of 75.5, and again, I rounded that, so it's not going to be completely accurate, equals the opposite side, which I'm going to call A, over the hypotenuse, which is 4. And again, to get A by itself, this is A divided by 4, so just multiply by 4. And I'm going to type this into Desmos. 4 times the sine of 75.5, and it better be super close to 3.87. So let's see. Again, I'm in degree mode. Let me just double check. I always want to make sure. Yep. So 4 sine of 75.5. And look, 3.87. So another way to go about finding that missing side length. So again, if you see the word solve, they want to know everything. All right. So sorry about that little blurb with the with finding side A using trig. Hopefully it all makes sense, and you look forward to a great trig lesson in class. All right, thanks for watching.